I was like really motivated and joined the competition way over my head. So I had like really basic knowledge, or not even basic knowledge, so below basic knowledge. And I joined the competition, which was about speech recognition. So quite a complicated task, but because I knew nothing in this field, there was a lot to learn. And I worked like really hard. Right now I did like more than 70 competitions in the 7 years. And by the points I accumulated in this 70 competitions, I have like the highest number of overall points in the world. And that like determines like the world rank. If you would join today and you want to become number one in the world, you would need to win probably 4 competitions just by yourself.
This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser. I'm a data scientist, and I will be your host. So today, our guest is Christof Henkel. He is a senior deep learning data scientist at NVIDIA. But Christof is also known for doing quite a lot of Kaggle competitions, and in fact, a couple of days ago, he became the world number 1 on Kaggle. Yes, quite an amazing achievement, number 1 in the world on Kaggle, so well done for this. And before NVIDIA, you also had quite a lot of experiences, including being the CTO of your own startup, and you also got a PhD in mathematics from LMU in Munich. So if the listeners enjoyed the conversation, please follow the podcast, subscribe, share, and leave a 5-star review. And yeah, that's it. Let's begin now. Hi, Christof. Well, first of all, again, a big congrats on becoming world number 1 on Kaggle. How does this feel?
Hi, thank you, Neil, for having me. Of course, that feels awesome to be ranked number 1 in the world. I've been ranked number 1 before, like 2 years ago or so, but it still feels like an amazing achievement to regain the rank.
Yeah, amazing. Well done. And we're going to talk about Kaggle later on. The first thing I want to talk about is how everything started. I'm keen to understand how you actually got into data science and got into the field. I understood that you were doing maths before, so how did this transition happen?
So my PhD in mathematics was related to stochastic processes and financial markets, so nothing to do with data science. But right after the PhD, I was just curious about AI and neural networks, and because I was already reading in the newspapers and just hearing it on the news, but I was very curious what this fuss is all about. So I was just looking on YouTube if I can find any high-level explanation or so on. So I was watching a few videos and explanations and training videos. And I was really fascinated in how this works and how the machine learning and especially deep learning works. So I jumped right into a free Coursera course, which was offered like 6-7 years ago. That was my starting point. And right after the Coursera course, I was looking for like a hands-on project I can try and practice the very first skills I gained there. And that's how I found Kaggle, and I joined my first Kaggle competition, and then it went on and on.
So when did you actually start? Was it during your PhD while you were learning maths, or was it after your PhD that you started to get into data science?
I would say it was like in the last few months of the PhD. So the thesis was already done, but I hadn't the defense yet. So there was some spare time in between, and I was like working part-time and had some free time suddenly because I didn't have to work anymore on my PhD. That's when I started looking into data science.
And why not staying in maths? Why switching fields?
I mean, the PhD specifically is really theoretical. So the only thing would be like to stay, even if you work like in the industry, it won't be that theoretical. The only way which you can really stay close to math and what I was doing in the PhD would be to stay in academic career. But that was not really an option for me, just because it's very tricky to have like harmony within your, like having a family or starting a family and all these things while pursuing an academic career is really difficult. So that was never an option for me.
Okay, and so you chose data science. I guess you stick to it. For how long have you been in the field now? When did you start?
I started 7 years ago.
Okay, so 7 years in the field, and I'm curious to understand if you think that your maths background actually helped you to get into the field. Obviously, there is quite a lot of maths involved in data science. So did this background help you, or did you feel like you were more starting from scratch?
I would say, of course, it doesn't hurt if you know like math, especially like linear algebra, where you do like a lot of matrix calculation and this kind of things. I think it's important to have like a basic understanding of math, so you can like follow like the background of all the deep learning and the calculations. But what is more important to be like really highly skilled in like data science and especially machine learning and deep learning is rather the ability to solve problems analytically and solve problems like in a structured way. And that's something you really learn during like studying mathematics or doing a PhD in mathematics. So it's rather the problem solving ability that you learn than the actual math that is useful.
Yeah, I think that's a good point. And I studied engineering, civil engineering, and I think it's kind of the same pattern. In civil engineering, you learn to solve practical problems using maths, like how to design a bridge or how to design a dam. And in the end, you've got lots of maths, lots of tools that you need to use, and you need to get to a solution. And I think that this kind of mindset is very important if you want to become a good data scientist, because in the end, your job is to solve problems.
Yeah, exactly.
And about the maths specifically, like how important do you think it is to know the maths behind deep learning algorithms, for example, or behind XGBoost? For people who are getting started, is it really important to deeply understand how those algorithms work, the maths behind them, or do you feel like, yeah, solving problems and knowing how to use those tools is more important?
For the beginning, I would say the later. So just like knowing how to use the tools is more important just for like the beginning. And nowadays it's even easier to use. Like there are a lot of high level frameworks where you just do something like model.fit and it runs the whole mathematical shenanigans in the background, and you don't need to know anything about it. So for beginners, it's fine to have like very, very little knowledge. But as soon as you want to develop more skills, it basically you need to like really dive into like why things are happening. And that's part of the problem solving. So in order to solve any problems you have while you're training or you have problems in your architecture, you need to understand the background and why those problems occur. And this often has to do with like the mathematics behind.
So yeah, so the more, well, yeah, if you want to solve problems, in the end, you're going to have issues that are related to the maths behind those algorithms. And so if you don't fully understand the maths behind the algorithms, you're going to get issues while solving the problem, and you might not be able to understand where those issues come from. Is that what you mean?
Yeah, exactly. But as a beginner, it's like good enough to just like understand your data and throw some quite easy algorithms onto it and just see what comes out. I think that's good for a beginner and to learn about like how this kind of models and so on are training, how this kind of things work. But like if you want to be more proficient, then you need to have some mathematics.
Yeah, I kind of agree, and I like your thoughts on starting practically and then digging into the maths. Like I think many people do the opposite. Like they will start with an algorithm, try to really deeply understand the maths, and then maybe start implementing it. I think that's fine. It's fine to read also how the algorithm works, but I find it more efficient to start just coding, see a bit how the algorithm works, how do you solve a problem with this algorithm, especially if you're a beginner and you don't really know how algorithms work and how well a machine problem is framed, a machine learning problem is framed. And so, yeah, I think it's a great idea to start by, well, knowing a little bit, having a bit of background knowledge about the algorithm, but don't dive into the maths. Start implementing, coding, doing a project with the algorithm. And once you understand how it works, then you can dive into the details. And I think you will better understand the maths if you've already done a project or already had some experience with the algorithm. It's very difficult to fully understand the algorithm by just reading maths. That's my view on this.
Yeah, exactly. It's even like way easier to understand the math behind if you know the problem first. So if you know like the problem and how the model is doing, then you have like a hands-on example to apply the math and to follow any equations and stuff.
Mm-hmm. Yeah, that's why I think doing a project or having a full-time job is great. Like at uni, you learn all those algorithms and you understand them somehow, but it's only until I started working that I fully understood how machine learning works and how those algorithms can be implemented. So yeah, let's dive into Kaggle now. We talked a bit about how you got into data science and few advice on how to do well. So you mentioned that you started by taking a free Coursera course and then you started getting into Kaggle. So first of all, first question for the listeners who don't know, what is Kaggle? Can you explain very simply what is Kaggle and why is it a great tool for data scientists?
So I think Kaggle started as a website 12 to 13 years ago. They were hosting machine learning competitions. That's what Kaggle is known for. But since they started, it now has become rather an online community for data scientists. So competition is now only a part of what Kaggle really is. They also offer like thousands or tens of thousands of data sets also. And they have like a huge community. There are like over 14 million registered users. So 14 million data scientists who share discussions, who share code notebooks, who compete on these competitions, who share data sets and discuss data sets and like throw models at those data sets. So and all this community gives you like rewards if you share things. So they incentivize you really in sharing. You can earn medals for sharing. You can earn medals in those competitions. And yeah, it's really like the go-to place for any data scientist to learn in specific fields. And even if you like on your real day job, I often just ran to Kaggle to find like a data set related to my day job, basically, because there's so much knowledge and stuff on there.
So not only machine learning competitions, it's also about collaborations and data sets and learning new tools. Like it's a lot of learning on the platform and it's not just about competitions.
Yeah, it's really hard to just like summarize what they are offering because they're adding more and more features to it. So nowadays you can even host your own in-class competition. So if you are like a professor and you want to have like a real hands-on study with your students, you can host like a playground competition by yourself quite easily, and your students can work on like a project. those kind of things. So it's now, I think they like a month ago or so, they started a Discord channel where you can have like a huge like discussions on the Discord and so on. So that there's more and more also evolve to host more and more aspects of the data science community. And I think they have been bought by Google in 2017. That also helps. So a lot of research problems are discussed and hosted on Kaggle, where like people can like work on research problems. So yeah, it's getting bigger and bigger, and it's like the go-to place for learning data science and machine learning.
And so why did you join Kaggle? How and why did you join the platform?
So right after the Coursera course, in those courses, you get some theoretical knowledge and some very basic practical knowledge by just answering like multiple choice questions, or you write some code snippets, but you don't really have like a hands-on project where you can practice your skills. So I was thinking, or I was searching for like a data set where I can just like try the stuff I've learned at this free Coursera course. And that's how I found Kaggle. And then where I found, okay, they host like a whole competition, which is just for one specific project where you can like work on for like 3 months. You have other competitors. You can compare yourself on a leaderboard, and you can really get like direct feedback how good you are doing just by seeing how far up or down you are on this leaderboard and how beneficial any new models or new techniques really are. And I was like really motivated and joined the competition way over my head. So I had like really basic knowledge, or not even basic knowledge, so below basic knowledge, just a few lines of like Python programming. And I joined the competition, which was about speech recognition. So quite a complicated task with a lot of deep learning involved. And yeah, but because I knew nothing in this field, there was a lot to learn. And I worked like really hard for 3 months. I learned an immense number of like algorithms and models and techniques and so on. So I spent like hours every day, and then I finished like place 500 out of 1,000 teams or so.
Which isn't bad.
Yeah, it's not bad for the very first experience. And then still, I was so happy that I learned so much things, and I was really motivated. And like a day after the competition was finished, I just joined the next one, which was like a completely different topic, and then you start from zero again. And I finished like 100th place of 1,000 after 3 months. And so you gradually improve your skills and improve what you know, and step by step, you become better and better in the field.
So just to make sure this is clear for the listeners, like a competition would be, for example, let's take a very simple example where you need to predict the price of the house. And so you've got a training set where you can train your model. You've got a test set where you're going to be scored. You're going to be scored on this test set, and there is a metric, for example, mean squared error or mean absolute error. And so you submit your model to the platform. The model gives you a score based on the performance on the test set, which obviously you don't have access to, otherwise it's a bit too easy. And so the leaderboard is based on the score on this particular metric. Is that correct?
Exactly. And then there's one interesting twist is that during the competition, so the 3 months, you have a part of the test set, which is called the public part. And that's what you see on the leaderboard during the 3 months. But then right when the competition is over, you are evaluated on a different part of the test set, which has never been seen or used before. That's called the private part. And that determines your final rank. So the quality of your model at the very end is really assessed on a completely new set you never have seen and you never have had like access to. And that's what makes it so valuable for like the real life. So there are some competitions where people spend like 3 months overfitting on the public side because they see every day, okay, I can improve my score by doing this and this and this. And then at the very end, they drop like hundreds of places just because their model doesn't generalize well to really new data. And I think that's a very important skill you learn for your day job, to not like overfit on a test set and generalize well to really new data.
So is this frequent? Are there many teams where they just try to, overfit the test set, and in the end they start to,
I think it's really a beginner issue. Mm-hmm. So that's a hard lesson every beginner will learn, that because it's like it's like also a psychological thing that you see you growing on the leaderboard and you want to be better and better, and you don't have like this long-term thing in mind. You just are so focused to improve day by day. And it's also really competition specific. So some competitions really easy to overfit to the public leaderboard. For some, it's way harder. So it depends a little bit. So there are really competitions where you drop like thousands of places if you're not careful, and others you can try to overfit as much as you can and you just drop like 1 or 2 places. So it's really like different, but it's important to understand like the risk you're having and so on.
What are the things we can do to make sure we don't overfit? What do you do to make sure that your algorithm is not overfitting?
I mean, I spend a lot of time in building a reliable validation set. A validation set that ideally reflects your test set, basically. So you rather use information coming from this validation set than using the information you gain from the public leaderboard. That's like the best approach, if it's possible. Sometimes in some competitions, the test set really comes from a different domain, and addressing this domain shift is like part of the competition or part of the problem. Then it's really hard to get like a reliable validation and to generalize well on the private part, because you don't have like a reliable approach. But in general, I think having a very good validation setup is like the most important thing. And it's also a very, if not the most important thing you learn for your day-to-day job, I would say.
So by validation set, what you're doing is you're training your model on a training set, and then do you fine-tune you fine-tune your hyperparameters on this validation set, or this is kind of a second test set in some sense that you really don't see?
Yeah, it's what you normally do. You split off a part of your training set, and splitting off needs to address somehow the discrepancy between your training and test set. So for example, if let me think of a good examples. If, for example, you have a training set of products coming from one region or coming from different regions, and your test set is from another region, then you should also split your training set in a training and validation part by region, so that in your validation set is a new region and you don't train on this region already, because it needs to reflect that you want your model to generalize well on new regions, things like this. And for this, you already need to understand the data a little bit. So you need to spend some time on understanding how the test set is different to the training set, and then try to replicate this difference also in your training and validation split. And then you can do whatever you want on your validation, mainly evaluate your model, tune hyperparameters, and so on and so forth.
Okay, great. And so you do this so that your score on the public test set reflects your score, your final score on the unseen test set, right? If you only tune your hyperparameters on the validation set, you should have a similar score on the public test set and on the unseen test set.
Yeah.
And so maybe one last question on the beginning of your Kaggle career. I'm curious, what would be your advice for people who want to start learning and doing competitions on Kaggle? Do you need to be already advanced to start a Kaggle competition? It looks like no, based on your experience. But yeah, what would be your advice if I want to get started tomorrow or in a couple of months? What should I do?
I think So your result or achievement will be directly correlated to how much time you spend on the competition. And that depends on how motivated you are on the problem. So first of all, I think people should choose not the easiest topic, but the topic or the competition which is most motivating for them or most interesting for them, even if it sounds hard or even if it sounds complicated and you don't have any experience. But if you're like interested in LLMs because you're like fascinated in what like ChatGPT and those kind of models can do, then you should join a competition which is related to LLMs. Because if you're like motivated in the subject, then you will like spend more time on this than if you do like some other project you're not really so motivated to learn about, but which might seem more simple or something. And then as soon as you joined the competition, you should start really simple. So don't over-engineer, really start as simple as possible and then gradually improve. That's the most important advice, because people tend to start with a big model, so they start with like good scores on their public leaderboard, and then over the time they drop in their scores and ranks, just because with a big model you can't do many experiments in short time, because it takes longer to train, it's more complicated, it's easier to like have any errors and things. But if you start with a very simple model, you can iterate faster, you can try a lot of ideas, this kind of things. So start with like a very simple model, spend some time in getting your validation right. I think that's the most important things that help you like in the long term. And with long term, I mean like 2 months working on a problem. It will pay off like in those 2 months. It really pays off if you spend like 1 week really starting simple and starting looking into the data and so on.
What are the steps that you take then to solve a Kaggle problem? You mentioned starting simple, but digging a bit more into this, do you have some kind of fixed list of things that you would do whenever you start a competition? I don't know, one, looking at the data, two, training a baseline. What are the steps that you usually follow? Or maybe there aren't and it's very problem specific and you don't have a fixed approach.
I don't have a fixed approach, but I have a rough approach that I often use. And that's basically starting on a high level, looking at the data, just to get like a feeling. Also, just for choosing the competition, if it makes sense or not. Sometimes the data has some flaws or there's like some luck involved and those kind of things. So I really... just a high level look at the data is enough to understand how big the data is, what kind of models and architectures make sense. Because for example, I'm really interested in deep learning approaches and deep learning models, but for some problems, deep learning just doesn't make sense. So I try to avoid those competitions and rather join ones where you can do like a lot of deep learning and more architecture engineering and this kind of things. And as soon as you have like a high level understanding how the data looks like, I implement a very simple pipeline for training a first model. Having done a lot of competitions, I already have kind of a boilerplate code. So I don't use any of the high level frameworks, but have like developed my own kind of code-based framework over the time. And I start using this. And then really design like the simplest model I can think of and set up a pipeline which runs really end to end, like taking the training data, training a model, evaluating the model, and also calculating the competition specific metric. Because for some competitions, the metrics are quite complicated and it can take some time just to implement or replicate how they evaluate your model. So having a very simple model, I use this to just to test if everything runs smoothly. And as soon as this first simple pipeline is set up, I continue with the next step. So that's the crucial thing. As soon as you don't have like this set up, a simple pipeline, getting like the competition metric, having a very good validation set, you don't need to continue because everything else you will do in the future will give you not good results, and you won't have any feeling how good the model will perform if you can't track like the competition metric. So this very step needs to be finished. So until I go to the next step, and the next step is then just like iterating through as many ideas as I have. So reading a lot of research papers, reading past solutions to competition which have been similar. So given that Kaggle hosts so much knowledge, you can also go through past competitions and read what people have done there. Read through research papers, read through GitHub repositories. So really a lot of reading, re-implementing, and trying as many ideas as you can, but still using a very simple model, just because that enables you to iterate more quickly. And at the end of the day, after like 2 months or so, it comes down on like who tried the most ideas. It's not like who had the most luck in finding something, but like finding something useful really depends on how much you tried, because 99% of things won't help your architecture or the problem. So it's all about trying as much as possible to find like the very specific thing that also differentiates you from other competitors. It's like more like a pro approach. I think for a beginner, it's good enough to just like try to get your own stuff as good as possible. And then the very last step, so the second step is all about research and iterations. And the last step is like scaling up your architecture and approach. So using a deeper model, using more data, using if it's like a computer vision problem, use higher resolutions for your images, this kind of things. But I only use this like in the last 2-3 weeks, where I already have like a rough solution in mind, and it's like really pitching or like coming really up with the final model I want to submit.
Okay, very interesting. So there are 3 steps. First is getting a baseline and a pipeline to run, so that you make sure you have a model that you can evaluate on the competition specific metric. Secondly, iterating and finding things that work for this problem, but while keeping a simple model, because it enables you to try many things. And then third step, in the last days, weeks, or of the competition, you try bigger models in order to boost performance, I guess.
Yeah.
And so on the second step, just one last question on this. What do you mean by what can you try if you don't change the model? Is it more on the data side, on the data processing side? Is it more on the hyperparameters tuning? Or what can you improve if you keep the model fixed?
There are so many things you can improve. So you can look at the data specifically. So you can filter the data, reduce some noise there. You can look at external data. So sometimes there are like external data sets which are useful. You can augment the data. You can do a lot of data augmentation, so the model generalizes better. You can use different losses. You can tune the hyperparameters. You can look into post-processing. So sometimes after your model predictions, you have some rule-based post-processing, which can help improve your score. So there's a lot of things you can do apart from the actual modeling.
Yeah, those are great advice, and I must say it's very similar. And I guess this is also why Kaggle is so popular. But it seems very close to just a normal data science problem that you would solve in industry, right? You, first you want a simple iteration. You want to make sure you can solve your problem, and then you build complexity. You need to pay attention to the data a lot. You need to also look at the post-processing. Once the output of your model is not always the final solution, you need to think about what it means and whether, you can make improvements or you can interpret this output correctly. So it sounds like it's quite close to data science in industry, actually.
Yeah, and I think it's really close. So sometimes people say things like, yeah, on Kaggle you only have like a play play data set on which you then run your models on, but that's actually not true. So most of the time, the companies that host this kind of competitions, they use like a relevant data set for the use case with all the perks their data has. So people can really like try to find solutions for problems they have in the data set. So it's not only like coming up with like a good model, but it's all about understanding the data, why the data has this kind of issues, and finding solutions in addressing these issues. And the solutions can be model based, so having a model that is capable of like addressing those kind of issues, so handling like missing data or this kind of things, or you can like address these issues by yourself by just like fixing missing data by some imputation mechanisms, or using like external data which has more higher quality, or improve the quality by yourself by hand, or so on. So there's so all kinds of things which are really related to the data and really related to a real day-to-day project.
Yeah, I see two things where it might differ from industry. And I mean, I think it makes sense that they're also not fully the same. Like those are just different things, but I see two different things. Correct me if I'm wrong. The first one is deployment. Like you're not deploying a model in production. And so most of the time, actually in industry, when you have this baseline, so this step one that we talked about, you have this baseline model, most of the time it's good enough. And you would just deploy this in production and move on to another project because you've solved your problem and you don't really care of getting another few percentage improvements by training, very big models. So in industry, sometimes you will just stop after step one. Obviously, you will need to interpret those results and you need to really understand your data. But once you're sure that you've got a good, simple model, because it's easy to deploy, because it's less risky, you would often stop after step one. So that's one thing that I see. And the second thing, it looks like Kaggle is still more model-centric than, whereas the industry is a bit more data-centric. What I mean by this is it looks like model is quite important in Kaggle, and it looks like in industry, data is more important because on Kaggle, you've got a fixed data set, whereas in industry, you don't even know which data you're going to use. Like you don't have a fixed data set. You need to look, sometimes you need to collect the data, create the data, and then only after that you can train your model. But in Kaggle, you're already kind of given the data, and so it solves a part of your problem. Do you agree with this?
Partly.
Yeah, I mean, it's good to disagree as well. I want to have your view.
I mean, with respect to deployment, so in the most recent competition, so since a year or two, Kaggle shifted towards like forcing participants in not submitting like the raw predictions, but submitting code to do inference on the test set. And there you already need to put a lot of focus on efficient inference. So you need to basically have your model deployment ready, but the scale compared to industry is way, way lower. So it's like you need to do something with respect to inference and deployment, but it's not something that is like production ready and scalable to like customers and this kind of things. So it's like deployment light. So it's called. And then I'm agree with you like that in the real world is really like data centric, and also the metric, for example. So in each Kaggle competition, you're given like a final metric on which you're evaluated.
Yeah.
But in the real world, like just getting to the point where you have like a metric that reflects your business case, that can be like hours of discussions with like different stakeholders just to find some value how you measure performance. And for Kaggle, all this step is already done, and you're just given like the value the final choice of metric which should reflect the business case. So I was like, and we can talk about this later, I was working in the startup, I had like so many discussions just to find like a good evaluation metric reflecting the business case. There's like more than half of the time spending on a project sometimes just goes into this.
Yeah, same actually. That's a very good point. I didn't think about the metric, but I remember one of my first projects at my previous company, Ioka, was I spent like a week trying to find the right metric, because if you get the metric wrong, you can have an amazing model performing really well. It's just not going to solve the right problem, and it's just going to have no value. So definitely metric is a important and sometimes quite difficult thing to set up. But yeah, I'm curious now. I mean, we talked a lot about Kaggle, the competition, how it works. I'm not super familiar with Kaggle. I've done some basic stuff on the platform. So yeah, it was great to learn more about it. I'm curious to go back to your career and understand a bit how you got from becoming, well, top 500, top 100 to what you are today, like world number one. How did this work, and how did you evolve from getting started to becoming world number one on Kaggle?
So let me first explain what world number one means.
Mm-hmm.
So there's a specific ranking related to competitions. So in each competition, after the competition is over and you're evaluated on the private leaderboard, you can earn a medal. So they're like bronze, silver, gold medal, depending on your placement at the end. So if there's like 1,000 teams competing, and that's like the rough number in this kind of competitions, if you're getting into like top, I don't know, like top 100 or so, you get like a silver medal. If you get like in top 10, you get like a gold medal. That's like the rough estimation. And like the top few teams, like the top 3 or top 5, really depending on the sponsors, also get like some prize money or other benefits and so on. And additionally to those incentives, you earn points for each competition. And those points depend on the final placement you have, how many people participated, because it makes a difference if you're like 9th place out of 10 or if you're like 9th place out of 1,000, and the size of your team. So because Kaggle really fosters like teamwork, you can also compete within a team up to 5 people. And of course, people who like competed in a team of 5 get like less points than people who competed by themselves. So those 3 factors determine how many points you get after a competition. And then over multiple competitions, those points are basically aggregated and they determine like the world ranking. So right now I did like more than 70 competition in the 7 years. Oh. And by the points I accumulated in this 70 competitions, I have like the highest number of overall points in the world. And that like determines like the world rank. But the way how I got there was really like gradually improving. So I started, as mentioned, the very first competition. I got like rank 500 out of 1,000, although I spent like hours every day working on this problem. The next one I got like rank 100 out of 1,000. The next one I got like rank 50 and so on. So I gradually improved and I gradually like improved the skills and knowledge and also the code base I have. So when I started, I barely couldn't write any Python code by myself, and nowadays I have like a whole bag of like code repositories I can look into of like similar things I've done, and know where to find similar things and so on and so forth. So it really like it's a gradual process over like 7 years, continuously working on this kind of problems and projects.
Okay. Is there some kind of recency weighting of your points? Like, for example, if I join, today, I guess, let's say I've been joining for a year, can I become number one, or is that very difficult because you've been here for 7 years? And is there some kind of recency weighting in the score?
Yeah. In the score, there's like a decay. So each day points decay. But just to give you some indication, if you would join today and you want to become number one in the world, you would need to win probably 4 competitions just by yourself. So that's like, so in the 7 years, I won 7 competitions, and I got like dozens of top 3 placements or so. So that's roughly like the range which you need to become like into this kind of area.
Yeah, still a long way to go, I guess, if I'm just starting, which makes sense. I wouldn't assume this to be easy.
But the interesting thing is that I think at the beginning the world ranking is not even like the focus of like the incentivization. So Kaggle also, and we haven't talked about this yet, but Kaggle also has like a tier system. So you start as like a beginner and you can advance to like an expert and then a master, and then the final step is grandmaster. So there's some, and then there's some incentivization to reach like this different levels, because you see what rank other people have and so on and so forth. So, and only after you achieve like the highest rank, you start focusing, okay, so what's next now? Because I'm already like a grandmaster, what I do now. And then you start looking at this world ranking, which is spanning across like multiple competitions and so on.
Can we dive into one particular Kaggle problem, that's Kaggle competition that you won or you were close to winning, just to get a feel of what a competition could look like? Do you have one in mind?
We can talk about the most recent one. So I was very lucky to win a competition 2 weeks ago, I think. And I had a great team with the one teammate. And the competition was about American Sign Language finger spelling. So the thing is, someone who's like communicating with a deaf or hard hearing person, they use sign language. And more specifically in America, you have American Sign Language, which differs from other like European sign language and so on. And in this specific sign language, there's a part which is all about finger spelling. So spelling not words, because for words normally you use like a sign for a word, but the use case is rather spelling a phone number or spelling a web address or spelling an address or something. So you have like per character, you have like a sign, and then you spell on the camera. And this competition was about having like a video where someone spelled like phone number or something, and you need to transcribe into the actual text. So it sounds like quite a complex task, and it is quite a complex task. And this competition was very, very interesting. There were like 1,500 teams competing. The prize money was quite high, and it was sponsored by Google at the end of the day. And the interesting thing there is that it has a lot of similarity to speech recognition. And you can really learn and read a lot from speech recognition and try to apply to the sign language. And I really like about these competitions that you also dive into the domain. So just like working on these problems and seeing like really looking at the data and seeing how people like sign, like the signers are really different too. So they have like different kind of how they spell. They're like left-handed and right-handed signers. They are like get closer to the cameras. They're faster or slower. It really like makes a lot of difference. And you need to basically take all these things into consideration to do well in the competition, because at the end of the day, you will do as you will to like recognize the finger spelling as accurately as you can. That was really, really interesting competition. And it also had a quite, coming back to your deployment into production thing, this competition was special because there you already had to submit a deployment ready model. So the model had to be converted in a TensorFlow Lite format. They can, in theory, just deploy via a mobile app they have. And that gave you some additional challenges, because you need to put a lot of focus in converting into the specific format and making it as efficient as possible, with like high restrictions. So the final model size should be lower than 40 megabytes, and it should need less than 100 milliseconds per sample and this kind of things. But I think that's not the typical use case. So normally it's easier to submit, but in this one, that gives like an additional interesting challenge.
So just to make sure I understand, I mean, it was quite clear, but the training data, like one raw data would be like a video of someone doing signs, and the goal was for you to transcribe what they were intending to say.
Yes, roughly. Yeah, roughly.
Why roughly?
It's a bit more complicated because they didn't give you like the actual video, but they used a model to extract key points from the video.
Okay.
Just to anonymize the people and to have it run faster on a mobile phone. So you're not getting the actual video, but you get like 500 key points of the person. And those key points are something like pose key points, like shoulders or like your nose and so on. And then key points within your hand, like fingertips and knuckles and things. And also like key points in your face, like ears and eyes and lips and so on. So the raw input data you have access to is rather a sequence of these key points, which are extracted from the video sequence. And that's what I'm saying. It's more complicated to explain, but it's like just one step in between from the original video. They extract those key points, and you were given those key points with all kinds of issues those key points have, because the model they're using using to extract those key points. This model also has like makes a lot of errors. So sometimes you cannot see the hand in the video, then you have a lot of nans in your key points. Or sometimes the person does like, I don't know, weird things, and then there's also stuff missing or things like this.
And can you give a simple framework or view of your solution, and why do you think that your solution was better than others? Like, what are the one or two smart things that you implemented that you think made you win?
So technically speaking, my model was an encoder-decoder architecture, where the encoder is a mixture of convolution and transformer. So convolutions are really local functions or building blocks, which consider like just small areas together. And transformers have like a wider range of interaction of the input. And combining both was like really powerful for this approach. And the actual architecture I took from speech recognition, and we put a lot of effort into making the inference very efficient. So I would say half of our like the performance of our model just comes from having more efficient inference than other teams. And this enabled us to use a deeper model. So if you are like restricted in having a model which is only 40 megabyte, then if you can like have double the size of double as big architecture as other teams, then this gives you like a better result. And you can only have like a bigger model at the end if you run it more efficiently in the inference part. So half of our success was due to like really efficient deployment, really efficient like inference, and the other half was about like the model architecture, or the other part. And then one other key point I would say was all about augmentations. So because the test set was split by signer, so you don't have the same people signing in the test set than you have in the training set. So it's really important, and that's a very good choice from the organizers to split it this way, because that's the real world example. You want your app to be like very good on new people who are signing and not the ones you have been trained on, right?
Yeah, obviously.
So it makes sense to reflect this in your training and test split. And of course, we also reflected this in our training and validation split. So all these augmentations reflected like the difference in signers. So having an augmentation which makes someone sign faster or slower, or having it like rotate their hands, or having it closer or further away from the camera, and this kind of things. So we implemented all these augmentations by our hand, and this really helped us to generalize very well to new signers. And I think that was like also a huge part of our success.
Okay, amazing. So, and this you won this competition, right? Well done. Yeah, looks, and it's very funny because actually the last episode I had a conversation with Davis Blalock, who was the first employee at Mosaic ML. I don't know if you know this company which got acquired by Databricks recently. And he also mentioned that efficiency is actually an indirect, making your algorithms more efficient is just an indirect way of making them better. Because if you can make them more efficient, you can make your algorithms bigger, or you can train longer, and in the end you will have a better model. And it's maybe something that we don't, I mean, now it's obviously becoming very popular, but I think it's not something that I realized myself. But yeah, efficiency is a very, very important part of the AI space. And yeah, I guess, well, you're doing this quite a lot at NVIDIA, and I want to touch on your role at NVIDIA now. But yeah, I think efficiency, making your algorithms more efficient, will just indirectly make them better.
Yeah, I fully agree. And you also need to really understand the algorithm and model very well, coming back to the mathematics and stuff behind, to make it more efficient. So in order to make it more efficient, you need to understand what it's doing and what you can like twist or change to run it more efficient.
And that's why you need to, at some point, if you want to become an advanced data scientist, you need to, understand the maths behind the algorithm. So maybe one last part on Kaggle. We talked a lot on Kaggle. I also mentioned that you're working at NVIDIA. The two are actually strongly related, but can you explain a bit what's your current role at NVIDIA and why Kaggle and NVIDIA is very strongly related in your case?
Yeah, so in my and our case, so I'm part of a team within NVIDIA who are called the KGMON, which is an acronym for Kaggle Grandmasters of NVIDIA. So we are only Grandmasters, and there are, I think, only 300 Grandmasters in the world on Kaggle, out of this 14 million people registered. So our team are eight Grandmasters from Kaggle. And our main role is to participate in machine learning competitions, not only Kaggle, but also like other platforms or competitions related to conferences like NeurIPS or CVPR and so on. So it's a really high synergy between like both worlds. So like the competition world and within NVIDIA. And the idea is that we bring the knowledge which you build or you need to do like very well in these competitions into NVIDIA. So because in the competitions, you not only need to apply state of the art and you need to have like an overview of what is the state of the art, but you need to like put something on top, not only yourself, but other top teams as well. So we have like a really good overview and feeling what is like the next state of the art, what is like the next things that are like relevant the next half year or the next month. And we bring this knowledge into NVIDIA, working on like internal projects or working with clients. That's like half of the idea. And the other one is that we also use NVIDIA products and like algorithms in this kind of competitions, and we can give like feedback, how good they're working, what features are missing. So we have like connections to all kind of internal teams and testing hardware and software and giving feedback. Okay, for this and this type of problems, we need this and this feature to do very well. So giving them some really hands-on experience, what is needed by the industry, and working together with them and implementing this stuff.
And the first part, if I don't understand well, you're reporting to NVIDIA what are the architectures that work and stuff like this. Is it to shape their products and their research directions, essentially?
Essentially, yes. So yeah, shape and like contribute to discussions there. So for example, if there's like a competition in the space of speech recognition, so right now there's a competition ongoing with like Bengali speech recognition, and people really share what is like state of the art for speech recognition. Then after the competition, we discuss with people within NVIDIA who are working on speech recognition and doing research and having a product. So there's like Nemo automatic speech recognition toolkit, saying, okay, that's the most recent models. They won this competitions. Mm-hmm. You should include them if you not have them already in our products. We tested this and this model which you have. It did well or not so well because of this and this reason. So really bringing like both worlds together.
Okay, and basically making sure that the products of NVIDIA are really targeted to the data science industry and to the latest trends of today.
Yeah, exactly.
Very cool. And yeah, obviously it's very closely tied to Kaggle because most of your time is spent doing Kaggle or other competitions, which is why, yeah, we talked a lot about Kaggle, but it's also very closely related to your job at NVIDIA. I want to now move to the last part of the episodes, closer to previous experiences and career advice. Just two main questions, actually. The first one is, I mentioned that you were the CTO of a startup before you joined NVIDIA. So do you want to talk a bit about this experience of founding your own startups and the learnings and failures that you got along the way?
Yeah, so it began not by founding this startup, but like one step before. So I was working in an insurance company, and after I started working like in data science and Kaggle competitions, I transitioned there to a team which was focusing on data science. But unfortunately, they were not applying so much deep learning and like the higher machine learning skills. So I was quite frustrated that I could not use my skills and apply my skills to like the day-to-day projects. So that's where I made the choice to start my own startup, which can focus only on deep learning based solutions or deep learning consultancy. And I was lucky to have done my PhD with two others who were also just like starting with machine learning and looking in this deep learning things. So we had the idea of funding the startup and then providing deep learning based consultancy, not only nationally, but also internationally, because luckily, because of Kaggle and stuff, you also build like a very good network of like data scientists all across the world, because Kaggle is like internationally. There's like people all across the world are working on this platform, and you you see like the same faces, and you see the same people performing well, and so on and so forth. So you build like a great network. Then we founded this company and worked on what first tried to get like projects and work on projects with clients.
Yeah. When was this? Like which year? Was it after the deep learning boom? Like during the deep learning boom?
In the beginning, I would say. So it was like 5 to 4 years ago. So we founded 5 years ago, and then I stayed for 1 year before I joined NVIDIA.
Okay.
So the boom, it's tricky because the boom worldwide, or the boom in the US, is like before the boom in Europe. So it was like already booming in the US, but it was slowly starting in Europe and especially Germany. So that's why it was a little bit frustrating, because I was like really by Kaggle and this like internationally network, I was like seeing what is happening and what's possible with deep learning. But the companies in Germany were lagged a little bit behind. So that's where we thought, okay, that's a good starting point to help accelerate this process. and help people getting started with deep learning and so on.
And why did you stop there? And are there any learnings or failures from your journey there?
I stopped simply because I got a dream job at NVIDIA, so I can like do Kaggle competitions or other competitions and work at like a great company at the same time. So I was happy at the startup. I really liked being like your own, you're like self-managed basically. But I would say the downsides, especially if you have like a very small startup, so we are only like 4 people at the end. So we had to do everything by ourselves, like sales, marketing, also things like taxes and health insurance and whatnot. So this takes a lot of time and takes a lot of your day-to-day business comes down to dealing with this kind of stuff and not really working on actual problems. And I really like problem solving. So that's what like inspires me and fascinates me, is like to really do problem solving and not do problem solving related to tax issues, but do problem solving related to data science. So I think whoever goes into the startup scene needs to be aware that there's a lot of stuff to do which is not related to whatever field you're working on, but it's related to bureaucracy and related to like getting your startup up to speed and like get your company working at the end of the day.
Yeah, especially at the beginning, if you're just 4, I guess there are quite a lot of things you need to do that are unrelated to AI. And so you wanted to, I guess, remain specialized in AI and keep doing more of AI, which is why you left your startup and you moved to NVIDIA.
Yeah, exactly.
Great. Okay, let's finish the episode with just one advice. If you had one advice for a data scientist to progress in their career, what would it be? Just one advice.
I would say just start working on a Kaggle competition. Because without joking, Kaggle is like the most efficient way to build up knowledge. Just because you're working on a hands-on project. There's nothing more efficient than really working on the project. You can read like tens of books or whatever, but just working a week on a competition, you will gain much more knowledge related to data science, and it's also more applicable to the real world, because you need to take care of all the most important things. You also need to take care in the real world, which is like solid validation, helping your model to generalize well, all this kind of things. You really learn in an efficient way on the Kaggle platform.
Well, Christof, thanks a lot. Learned so much from you today. It was great to chat with you. Good luck with everything. Hope you will remain number 1 forever. Although that might be difficult, but yeah, good luck.
Yeah,
yeah, catch up soon.
Yeah, thank you. Thanks for having me. It was a great experience.